Some of you might already know the equation of a circle because you will have seen it at GCSE. It is a GCSE topic, but some of you won't. So we'll go through it and talk about how it occurs in A level. So this is the equation of a circle. X minus a squared plus y minus b squared is r squared. And the point AB is the centre of the circle. And the number r is the radius of the circle. Okay? So for example, say this is the point minus 2, 3. Then my A is minus 2, because that's the centre of the circle, x coordinate. And my B is 3, because that's the centre of the circle, y coordinate. So my equation would be x minus 2 squared plus y minus 3 squared equals, and you can see from my picture that this is the radius here. So what would the radius be? 2. Excellent, because we're going 2 that way and 3 up. This is 2, this is 3, so the radius is obviously 2. So here we have 2, but not just the radius squared. So the equation would look like this: x plus 2 squared plus y minus 3 squared equals 4. Do you recognise that that shape of the equation? X minus a squared plus y minus b squared is r squared?
Well, I mean, obviously we don't, before this point, you don't deal too many with y squareds, do you? But this, the x minus a thing, looks a bit like a completed square.
Yeah, that's part of what pops out of a completed square, and the other half is also what could pop out of a completed square. The other thing that you might, when I draw it, you might think, oh yeah, just like that, is something that you see quite early on in history. Pythagoras, yeah. Pythagoras. So this is the radius here, and this is x minus a along here, and this is y minus b along here. So if you forget the formula, it is just Pythagoras, x minus a squared plus, because some people forget whether it's plus or minus, so Pythagoras is always plus, isn't it? So x minus a squared plus y minus b squared is r squared. Just normal Pythagoras on that right angle triangle. Okay, funny you should talk about completing the square. Sometimes we get an equation of a circle looking like this, and what's happened is someone's expanded it out. So if we go back to the one that we had a minute ago, this blue one, and expand it out, we get x squared plus 4x plus 4 plus y squared minus 6y plus 9 equals 4. Now I could write this bit first, and then this bit, x squared plus y squared, and then plus 4x, and then minus 6y, and then bring all of these numbers together, plus 9, and I could write it like that. Now, major disadvantage of this is that you can't see what the centre is, whereas if we write it like this, then you can see that the centre is minus 2, 3, and the radius is the square root of 4. So that's nice, but this form we can't see it. So what we need to do is go back in that direction, which, as you quite rightly said, is completing the square. So first of all, let's put it in an order that's a bit more useful for us. I'll do the x squared plus 2x, then the y squared minus 6y, and to be honest, I'm going to dump that 10 on the other side, out of the way. Okay, completing the square, x plus half of b squared minus half of b squared. Completing the square on the y, x, well, in this case y, plus half of b squared minus half of b squared. There's no plus c. And then all we need to do is move those numbers onto the other side. Okay, so the centre of the circle is what?
-1.
Excellent, minus 1, 3. That's the centre, and the radius is?
Root 20.
Root 20. Okay, so if you see it in that form, it's just completing the square of the x's and completing the square of the y.
One question that I feel might be worrying is mine right now. Why, when you've got plus 1 and minus 3, does it become minus 1 and plus 3?
Well, it is because the equation of the circle is always x minus the x coordinate of the centre. So if the centre is positive, then this will say minus, and similarly here, if the centre, it has a positive y value, then that will say minus. But if this b happens to be negative, then when we substitute it in here, we end up with 2 negatives, and then it becomes a positive. So really, this bracket says x minus 1.
Yeah.
And this bracket says y minus 3. So the 3 is the y coordinate there, and the minus 1 is the x
Has it
coordinate
got
there.
anything to do with the transformations then?
Yes, yeah, it's a good way of thinking about it. You know that when you have an inside transformation, it moves it left and right.
Yeah.
So x add 1 squared is left 1.
Yeah.
And y minus 3 squared is right 3.
Well, it won't be below.
Sorry?
Up.
Up 3.
Yeah.
Because it's the opposite of what you think. And it's y, so it's up and down. But it's inside, so it moves it up, not down. So this has gone left 1, up 3.
I guess from the
From the, yes, from there. So then you get your circle, and actually if I do that, then I can move the actual circle. No, I can't. I thought the circle would separate. I want the circle to separate. That should do it. So, left, what was I doing? Left 1,
Yeah.
up 3, left 1, up 3. So then it's going to end up with its centre at minus 1, 3. Yeah, that's another good way of thinking about it. Right. The most complicated thing in circles is where you get a line and a circle. Now a line could completely miss a circle, that's not very interesting. Or it could touch or cross in a special way right through the centre. Now there's some rules from GCSE which you need to remember. So for example, if I know this point here and this point here,
Yeah.
and I know it's going through the centre, how would I work out the centre?
Isn't it the midway point?
Exactly, midpoint, which we learnt in C1. Midpoint. There's another thing, I think this is more GCSE. If this goes through the centre and I create a triangle like this, what's special about that triangle?
The top point is 90 degrees.
Yes. So if this is 90 degrees, then this must be the centre, which means it's the midpoint of these two. And if this is the centre, and therefore it's the midpoint of these two, then the angle at the edge will be 90 degrees. What does that mean that we know about the gradient of this line and the gradient of this line?
A perpendicular to
Yep, so if this one's, for example, n, this gradient, what would we know about this gradient?
it's minus 1 over here.
Exactly, the negative reciprocal. So there's loads of geometry going on,
Yeah.
loads of things you can use, bits and bobs from GCSE and from C1. Got another one over here where it does, the line slices through the circle but doesn't go through the centre. Now what we can do is create this triangle like this. Okay, now what's the name for that type of triangle?
Isosceles?
Excellent, isosceles, because this is the radius, isn't it?
Yeah.
That's the radius, that's the radius. So these angles are the same.
Yeah.
What if I make a line down here? What's special about that point?
It will be the
Excellent. That one will be the midpoint of these two. So that might be useful. And we can find midpoint by averages, and this will be a right angle here.
Yeah.
So if we wanted to know, for example, this distance, this would be half of this distance, which you could get using these coordinates maybe. So there's all sorts of stuff that you can do, working things out, area of a triangle, angles, all that kind of thing. Now, in this last case, we've got a line which doesn't cross the circle at all, it just touches it. So this is actually a tangent to the circle, where it just touches, and when that happens, we create a right angle here. And like we just said, when you have a right angle, they're perpendicular gradients. So if you know the coordinates of the centre, and you know the coordinates of the touching point, then you can work out the gradient of the radius,
Yeah.
or this particular radius, you can work out. And then this one, this gradient, will be the negative reciprocal, because they're perpendicular. So one thing you could be asked is, what is the equation of the tangent? What is the equation of this line at the point, whatever,
Yeah.
3, 1. So if we were asked what's the equation of the tangent, what would we write down first?
The line, so m bracket x minus n.
X have a little think about what we're doing. But if we want the equation of the line, we write that down. We're told the point, so that can go in. We aren't told the gradient, so that's a problem. But if we know the centre of the circle, then we can use change in y over change in x, just like you saw in C1, to get the gradient of the radius. Flip it upside down and change the sign, and you know the gradient of the tangent. So, main piece of advice when you're doing circle questions is to draw a picture. Students, I mean, even having done like every C2 paper that's ever existed, can't do the part B, part C of a circle question without drawing a picture. So if you're stuck on a circle question, it's because you're not drawing a picture. So just draw a little picture, see what's going on. Maybe it's asking you for a distance. You can see that where something crosses the x-axis, so y is 0, so you could sub that in. Or maybe crossing the y-axis, so x is 0. Or maybe you need this distance, so you can use Pythagoras. Or maybe you can draw and see that you've got an isosceles triangle. Whatever it is, drawing a picture will help you to work out what to do.